Right, good morning. Today we want to sketch the graph of y is equal to x minus 1, x minus 2 squared. Right, to sketch this graph, first of all we need to find the intercepts. Right, what do we mean by the term intercepts? This is where the graph crosses either the x-axis and the y-axis. So we want to find the y-intercept and the x-intercept. So to find the y-intercept, the graph cuts the y-axis when x is equal to 0. So we are going to substitute for every x there. We are going to substitute it with 0. And for the x-intercept, the graph cuts the x-axis when y is equal to 0. So we are going to substitute this y with 0 to find the x-intercept. Then another thing, number 2, we have to find the turning point. How do we find the turning point? Right, we all know that at the turning point, our graph is a gradient of 0. So the derivative of this function should be equal to 0 if it's at the turning point. Right, so dy dx should be equal to 0. So we first find the derivative, then equate that derivative to 0 to find the turning point. Then the third concept there is to determine the nature of the turning point. The nature of the turning point. How do we determine the nature of the turning point? Right. To determine the nature of the turning point, we find the second derivative. And if the second derivative, if d squared y dx squared is less than 0, then this is a maximum. Right. Then the turning point will be a maximum. And if the derivative is greater than 0, then the turning point will be a minimum. Right. What do we mean by maximum and minimum turning points? For a maximum turning point, the turning point will be at a maximum. And for a minimum turning point, the turning point will be at a minimum. So those are the three main focal points when sketching any graph. Right. So to sketch that graph, to sketch this graph, y is equal to x minus 1, x minus 2 squared. Right. For the y-intercept, the graph cuts the y-axis when x is equal to 0. So when x is equal to 0, y becomes 0 minus 1, 0 minus 2 squared. And this becomes minus 1 times negative 2 squared. And this becomes negative 1 times 4. And this becomes negative 4. Right. So for our y-intercept, when x is equal to 0, that's when we have the graph cutting the y-axis. So that's our y-intercept. So our y-intercept there is 0, negative 4. That's our y-intercept. Then we move on to find the x-intercept. Right. Right. For the x-intercept, the graph cuts the x-axis when y is equal to 0. So that graph will cut the x-axis when y is equal to 0. So we substitute this y with 0, so it becomes 0 is equal to x minus 1, x minus 2 squared. So we are going to solve this equation. So it's either x minus 1 is equal to 0 or x minus 2 is equal to 0. X minus 2 squared is equal to 0. And solving that first equation, x becomes 1 or x becomes 2 twice. What does this mean? It means the graph is its turning point at x is equal to 2. Like what we are going to find out when we find its turning points. It's repeating itself at x is equal to 2. So these are our y-intercepts. So the graph is cutting the x-axis. The graph is cutting the x-axis at x is equal to 1, and obviously y is 0, and x is equal to 2, and y is 0. This is 2 twice. Remember, it's 2 twice. Right, then we move on to find the turning point. Right. This is a cubic function, so we are going to have 2 turning points there. For a quadratic function, we have 1 turning point, and for a cubic function, we have 2 turning points. Right, so we said at the turning point, our derivative should be equal to 0. So we have to find the derivative of this function. So we rewrite our function y is equal to x minus 1, x minus 2 squared. We have to expand this. So it's x minus 1, then this is x squared minus 4x plus 4. Right? And we expand this x squared minus 4x plus 4 minus 1, x squared minus 4x plus 4. Right. This becomes x to the power 3 minus 4x squared plus 4x minus x squared plus 4x minus 4, and this becomes x to the power of 3 negative 4x squared minus x squared, it becomes minus 5x squared, and this part plus 4x is plus 8x minus 4. Right, we now have our function y is equal to that. So the derivative of y with respect to x is equal to, we drop this 3 and it becomes 3x, we subtract 1 from 3, becomes 2. We drop this 2, it's minus 10x to the power 1, then plus 8. Right, that's our function there. Right, with that function, this is the function for the gradient of the curve. We said at the turning point, the derivative should be equal to 0. So at turning point, this should be equal to 0. So 3x squared minus 10x plus 8 should be equal to 0. Then we now factorize this. Sorry for that, I had a problem with my camera. I had to fix my camera, right? So we're saying at turning point 3x squared minus 10x plus 8 should be equal to 0, right? So we now want to find the value of x at the turning point, right? To find the value of x at the turning point, we are going to solve this equation. So 3x squared minus 10x plus 8 is equal to 0. We factorize this part. 3x squared minus 6x minus 4x plus 8 is equal to 0. Then we factor out 3x there. This x, negative 2, negative 4, x, negative 2 is equal to 0. So x minus 2 and 3x minus 4 is equal to 0. So either at turning point, either x minus 2 is equal to 0 or 3x minus 4 is equal to 0. Then we solve this. X is equal to 2 or x is equal to 4 over 3. Right. We now have the values of x. Right. The values of x being equal to 2 and x being equal to 4 over 3. Right, I've written them down there. X is equal to 2 and x is equal to 4 over 3. Right, so we now want to find the value of y when x is equal to 2 and the value of y when x is equal to 4 over 3. So we are now substituting our x into the function there. So when x is equal to 2, we have y being equal to 2 minus 1, 2 minus 2 squared. So y is equal to 1, 2 minus 2 is 0. So y is equal to 0. So our turning point is coordinates 2, 0. If you still remember, I once talked about this being our turning point, right? Then we now move on to find the value of y when x is equal to 4 over 3. So when x is equal to 4 over 3, we have y being equal to 4 over 3 minus 1, 4 over 3 minus 2 squared. So this becomes common denominator there is 3, 4 minus 1 into 3 is 3 times 1 is 3. Multiplied by common denominator 3, 3 into 3, 1 times 4 is 4, 1 into 3 is 3 times minus 2 is minus 6 squared. This becomes 4 minus 3 is 1/3, right? It's 1/3 times 4 minus 6 is negative 2 over 3 squared. Right, this becomes, it simplifies to 1/3 multiplied by 4. Negative 2 squared is 4 and 3 squared is 9, so it's 4 over 9. Then we multiply these two, it becomes 4 over 27. Right, so when x is 4 over 3, y is 4 over 27. Right, we now have our turning points there. So our turning points, let me write them here. We have 2, 0 and 4 over 3, 4 over 27. So those are our turning points. Right, after that, we now have to determine the nature of the turning points. How do we determine the nature of the turning points? We have to find the second derivative. Oh, I erased the first derivative. I'm sure the first derivative dy dx was the first derivative was I'm going to reverse this. So it was x minus 2 and 3x minus 4. I'm sure. Right. So this was, we expand this x, 3x minus 4 minus 2, 3x minus 4. This becomes 3x squared minus 4x minus 6x plus 8. So it's 3x squared minus 10x plus 8. So this was our first derivative. So we have to find the second derivative. Right. Our second derivative, we drop this. This becomes 6x minus 10. Right. We now want to determine the nature of this turning point, point 20. So to determine that point, when x is equal to 2, what do we get? d squared y over dx squared is equal to 6. For x, we are going to substitute it with 2 minus 10, which is equal to 12 minus 10, which is equal to 2. 2 is greater than 0. So remember, we said if we find a value that is greater than 0 for the second derivative, it means the turning point is a minimum. So we have a minimum here. This one is a minimum. Right, because the second derivative is greater than 0. Then we want to determine the turning point when x is equal to 4 over 3. So when x is equal to 4 over 3, we have the second derivative being equal to 6. For x, we substitute it with 4 over 3 minus 10. This becomes 3 into 3, 1 into this 2 times 4, it's 8 minus 10. And this becomes a negative 2, which is less than 0. So for a second derivative which is less than 0, it's a maximum. So this point is a maximum. This one is a maximum. Now we are done. We can now sketch our graph. Right. We have the y-axis, the x-axis, we have our intercept, the y-intercept 0, negative 4. So let's say our negative 4 is here. This is 0, negative 4. And the x-intercept 1, let's see our 1 is there, and 2, our 2 is there. Then we said at the turning point 2, 0, our turning point is a minimum. This is our 2, 0. Our graph will be a minimum. It will be like this. Then at this turning point 4/3. 4/3, let's say our 4/3 is here, and 4/27, let's say our 4/27 is here. So this is the point 4/3 and 4/27 there. Right. So our graph is will be like, this is our first turning point, and the other turning point is somewhere there, right? Right. That's the function, the graph of the function y is equal to x minus 1, x minus 2 squared. There's a maximum there and a minimum there. Thank you for watching. Remember to subscribe, like and share to anyone who might need this, who might be in need of this. Thank you very much.